Let's do a fourth example of writing inequalities from a word problem. The rings are going to take us 6 hours to make, necklaces take 4 hours to make, 15 grams of metal make a ring, 40 grams of metal make a necklace. First, we're going to write an inequality to represent the number of rings that can be made in a 60-hour work week or less. So apparently we're putting in some overtime. I can't make a negative number of rings. It takes me 6 hours to make a ring, and I'm working for a maximum of 60 hours. Let's divide everything by 6. So 0 is less than or equal to x is less than or equal to 10. So if I only go by the number of hours, I could make as many as 10 rings. Now I want to write an inequality to represent the number of necklaces that I can make in a 60-hour work week or less. Necklaces take 4 hours to make. Again, I'm not allowed to make a negative number of, well, anything really. So 0 is less than or equal to 4y is less than or equal to 60 because it takes 4 hours to make a necklace. Let's divide everything by 4. That comes out to a nice clean 15. So based only on hours, I could make a maximum of 15 necklaces if that's all I make in a week. Now I need to write an inequality that represents the total number of rings and necklaces that I could make in that amount of time. Well, again, it takes 6 hours to make my ring. It takes 4 hours to make my necklaces, and I have at most 60 hours. I could put it in slope-intercept form. Or, to graph it easily, I could look at my intercepts. If I plug in a 0 for x, 60 divided by 4 is 15, so 0, 15 is an intercept. Plug in a 0 for y, 6x to 60 divided by 6, I get 10. Much easier to plot with my intercepts. Finally, we need to write an inequality to represent the number of rings and necklaces that I could make using 700 grams of metal or less. 15 grams make a ring, 40 grams make a necklace. 15 grams make a ring, 40 grams make a necklace, and they told me I have 700 grams of metal. I could put it in slope-intercept form, but truly the easiest way to graph this is from the intercepts. If I divide 700 by 40, 70 over 4 is 35 over 2 is 17 and 1/2. If I plug in 0 for the y, 700 over 15, I don't think I trust myself to do quite as good a job. 46 2/3. Let's see how all of these constraints look when we graph them. So now I have 2 vertical lines, 2 horizontal lines, a diagonal line, and another diagonal line. 6 constraints. I wonder what our feasible region will look like. When I graph all of my constraints, it's very interesting. Here's my x equals 0, my x equals 10. Remember, I would shade in between. Here's my y equals 0, my y equals 15. Again, I would shade in between, so far I'm trapped in this rectangle. Now, when I look at the total number of rings and necklaces I could make based on hours, I get this blue diagonal constraint. Now remember, it has to be less than. So now I'm in this triangular area. But I still had the diagonal constraint telling me how many necklaces and rings I could make based on the amount of metal available to me. What this tells me is I have more than enough metal to make all the rings and necklaces I could possibly make in a 60-hour work week. All I have left now is to find my corner points. Here, of course, is the origin at 0, 0. Here's a corner point of 10, 0, and up here, a corner point of 0, 15. Again, I may have drawn 6 constraints, but I ended up with a triangular-shaped feasible region.